All right, so we made it. We're ready to try out some KSP calculations. So I've got for us a few kind of simple ones to get started, and then we'll work our way towards a little bit more complicated ones, just like we have with our other chapters all the way along. So the first thing we're going to do is calculate the numeric value of KSP given some concentration data. So we're going to calculate KSP from concentration data. So here's our setup. If the molar solubility of PbCl2, which was one of those insoluble salts that we talked about last semester, is 0.160 molar. Calculate KSP. Well, I'm going to write out the equation for the dissolving of KSP. Even though it's already dissolved in this solution, we're going to write out the equation because that's what KSP is based on. So PbCl2 as a solid will be in equilibrium with Pb2 plus Cl minus, two of those. And the reason that we're starting out writing these equations, even though we may not need them when we actually work problems because they're relatively straightforward, I'm pointing out the stoichiometry that goes on here. The fact that one molecule of PbCl2 puts out one Pb2 plus, but two Cl minuses. That comes into play with our KSP because we're going to get our exponents from that. So our concentrations. If the molarity of PbCl2 is 0.16 molar, and there's one lead ion per molecule, that means our lead concentration is 0.160 molar. But our chloride concentration is not 0.16 molar because there are two chlorides per PbCl2. If the molarity of PbCl2 is 0.16 molar, the molarity of chloride ion must be twice that because there's two chlorides per molecule of PbCl2. So the concentration of Cl minus is 0.32 molar. If you miss that step, you can't get the right KSP calculated out of it because you have to recognize what the molarities are for each ion as they go in. So we write the KSP expression. That would be Pb2 plus times Cl minus squared. And we plug in our numbers. 0.160 times 0.320, that will get squared. So we grab our calculator. 0.16 times 0.32 quantity squared equals 1.64 times 10 to the minus seconds. That would be the KSP for PbCl2 based on solubility data. So when we know the molarities of the ions at equilibrium, we can plug them into KSP and calculate what the value, the numeric value of KSP actually is. Okay? We'll come back with one more.